So hey guys, welcome back to my channel. Hope you're doing extremely well, and this is your very own mask coder this side. So ask the question in meeting rooms. So what does the question say? The question is very simple actually. The question says that there is a company, right? There is a company, and we know in each company there are certain meetings held, right? But unfortunately, this company has only one meeting room. This company has a one meeting room, right? Now the manager receptionist who schedules meeting and it gets some requests, right? Request in the form of start and end. That is, it get requests from multiple people about the start time and end time. They require the room for the meeting, right? For example, in the given example, 1 comma 4 10 comma 15 7 comma 10, that is, first person says that I want the meeting room from 1 to 4. You can take it as minutes, you can take it as hours. Let us take it as hours, 1 hour to 4 hour. That is time. Okay. Second person asks that I want the room for 10 to 15 hours. 10 to 15 hours means 10 o'clock to 15 o'clock on a 24-hour basis, right? Third person says I want the room for 7 o'clock till 10 o'clock, right? Now as a receptionist you have to tell whether it is possible. If there is only one meeting room, it is if is it possible to schedule all three meetings, right? So if I try to think of it, what is it saying? If I try to plot them on a graph, right? So 1 is lying here and 4 is lying somewhere here. That is, I want a meeting to go from here to here. This is my first meeting. Second meeting says I want to start at 10, I want to end at 15, right? Second meeting is this much. Third meeting is 7, so that will lie something somewhere here and it will end at 10. That is this much, right? So you can see this first meeting is not overlapping with any of the meetings, so it can be scheduled. 7 to 10, this meeting is not getting overlap because when it is getting ended, then another meeting is getting started only then. So there is no overlap, right? So it is also getting scheduled, and 10 to 15 also getting scheduled. Now because all three of them are getting scheduled, so that you will turn true that this scenario is possible. You can schedule all three. Similarly, for this case, what is happening? First is 2, from 2 to 4. This is your first meeting. From 9 to 12, 9 to 12. This is your second meeting. Now 6 lies somewhere here and 10 lies somewhere here. Third meeting. Now this meeting is absolutely correct. This can be held without any overlaps. But you can see that in the second meeting and in the third meeting, this overlap region is there from 9 to 10. So because of this overlap, we cannot schedule the meetings together because this overlap will actually ruin the consistency of the meeting. So we will return false, that this scenario is not possible because there is only one meeting room. We will require at least two meeting rooms for this, right? Okay. Now this is the case, you have to return true if the scenario is possible, you have to return false if the scenario is not possible, right? So let us continue with, let us see how we will solve it. Let us try to visualize the graph only first, right? Let us try to visualize the graph. In the two cases above, I drew some examples like this. In the second case, something like this was happening, right? The problem occurred only because of this part. Only because of this part. What is this part? This part is an overlap. This part is an overlap. The answer lies there. The answer lies there. Your algorithm should detect the overlap. You have to write the algorithm. My objective is to identify if an overlap exists. If an overlap exists. If there is an overlap, return false. If exists, return false. Otherwise, return true. That is the only case. That is, you need to know that if there is an overlap happening. Now, let us see the example 2 again. What were the scenarios? Scenarios were 2 to 4, 9 to 12, 6 to 10. What is the basic condition for overlap? What is the basic condition? If you see, this is my x, this is my y, this is my z, this is my w, you can see that first meeting is x comma y, second meeting is z comma w, right? So for the overlap condition, it should happen something like this, that this z, start time of another meeting, should lie between x and y. That is, z should be lying between y and x. This is the only condition I need to check. So what can I do? I can just use a loop. So for these three scenarios, I can use a loop. That is for I going from 0 to n minus 1. That is for all the examples. For each case, go for each case. That is for j equals to 0 till n minus 1 and j is not equals to I. What will happen now? Check for this condition. That if jth item start time lies between ith item start time and ith item one end time. If this is true, if this condition is true, return false. That is, there is an overlap. If that this condition is true, return false. That this condition is an overlap. Otherwise, if both the for loops run fine, then return true. Right? What is the time complexity? You can see I'm going from 0 to n minus 1 here, 0 to n minus 1 here. That is O of n square. But, but, can I reduce the time complexity? Can I reduce the time complexity? Obviously, how? Let us see. So the scenario given to me were 2 to 4, 9 to 12, and 6 to 10. Right? Please understand my thing and sort them up. Sort them up according to the start time. After sorting, this would look something like this: 2 to 4, 6 to 10, 9 to 12. What did we do? Sort according to start time. If you sort according to start time, this would look something like this. Now, why did I sort according to start time? My basic algorithm is that if you sort according to start time, that is the time this meeting starts, right? Now, to detect an overlap, after sorting, if the start time of the I plus 1th meeting, start of I plus 1th meeting, is less than end of ith meeting, that means it is also an overlap. If the start of the I plus 1th meeting is less than the end of ith meeting, that means that this is a overlap. I will use that. Okay, what I'm saying is this is the start 1, this is the start 2, right? This is the, now where should I place end 1 such that there is an overlap? And 1 should be placed here only then it will be overlap. That is, start 2 should be less than end 1. That is the only thing, right? So what I'm going to do, I'm going to sort the array given to me. And now for I going from 1 up till n minus 1, if I0 is less than I minus 1th n time, in that case return false. Otherwise, is after this loop return true. Now, time complexity for this case is, for sorting it is requiring n log n, but earlier we were using n square for traversal, but here we are using only one traversal, so n for here. Overall, this complexity will overpower, so O of n log n is my time complexity, and my space complexity is O of 1, right? So I hope the message is clear to you, and let us now try to code it down. The code is actually very simple. Here is the coding section, guys. First and foremost, sort the array. We discussed it, right? This is also a question of greedy algorithm, right? Sorted the array. Now, for int I going from 1, I less than array dot size, I plus plus. What will you do? If my current element start time is less than n time of my previous element, in that case, return false. Otherwise, return true if all the cases are not obeying this, right? Let us try to compile and run it. Hope it will run fine and will not give any error. Working fine for the sample test case. Let us see for the hidden test cases as well. Running and getting accepted. So thank you for watching. Hope you liked it, and make sure to subscribe to the channel. Thank you. Have a nice day.